Hello everyone, welcome to Teacher Josie's channel. For today's video, we are going to learn about electronic configuration. Let's have first a review. What are the colors produced of the following metal salts? Strontium nitrate, sodium nitrate, magnesium, copper oxide. What do you think are the answers? Very good. Identify the following. It is the longest wavelength and lowest energy. It is the shortest wavelength and highest energy. It is the electron absorb energy and jump to a higher orbit. It is an electron emitted energy and return to original level. What do you think are the answers? The answers are red light, violet light, excited state, ground state. Very good. Another one. What are the colors produced of the following metal salts? Lithium carbonate, barium chloride, calcium carbonate, copper, and strontium. The answer are very good. Identify the following. It is the region around the nucleus where the electron is most likely to be found. It is an energy levels that can accommodate a maximum of 18 electrons. It emits characteristic color of light when heated. How many electrons can the orbital holds? What do you think are the answers? Very good, class. Now, in the previous lesson, we have learned that electron can only stay at a certain fixed distances away from the nucleus. This position is called energy levels. Each energy levels contain a certain number of sub-levels. Every sub-level has fixed number of atomic orbitals. This atomic orbital is the place where electrons are most probably found. The electrons in the atomic orbital carries a definite amount of energy. Now, tracking down the location of a given electron in an atom is similar to tracking where a person lives. To find this person, you need to know his complete home address, the city, barangay, and house number. This corresponds to energy levels, sub-levels, and atomic orbitals in an atom. The objective of this video, 1 is determine the pattern of filling the atomic orbitals based on the given electron distribution of the first 10 elements. The second, write the electron configuration of the elements in the third period of the periodic table. When creating electron configurations, we must first take a look at how the periodic table of the elements is separated based on orbitals of atoms. For group 1A and 2A, they belong in s orbital. Group 3A and 4A, they belong in p orbital except the helium, while the transition metals belong in d orbitals, while the lanthanide and actinide series, they belong to f orbitals. Electron configuration is the arrangement of electrons in orbitals around an atomic nucleus. The maximum electrons of S is 2, the maximum electrons of P is equals to 6, the maximum of electrons of D is equals to 10, and maximum electrons of F is equals to 14. In the electron configuration of 1s2, 1 here refers to the main energy level occupied by the electron. The S denotes the kind of orbital and the superscript of 2 for the numbers of electrons in the orbital. The main energy level also tells us the number of sublevels, and the name of sublevel is also the same with the name of the orbital. Here is an overview of the elements separated based on orbital of the atom. We have here the s orbital. The group 3 to 8A belongs to p orbital except the helium. The transition metals belong to d orbital, while the lower part here belongs to f orbital. Now, there are three rules applied in deriving the electron configuration. One is the outmost principle, which electrons will occupy the lowest energy level orbital that will receive it. The second, Pauli's exclusion principle. No two electrons within the atom may have an identical set of all four quantum numbers. 3. Hund's rule of multiplicity. An electron will occupy all empty orbitals in a subshell with a single electron having parallel spins before entering half-filled orbital. Now let us discuss each principle. Output principle is also known as the building up principle. States that electrons occupy orbitals in order of increasing energy. It follows this mnemonic in filling up the orbital. First, you have the 1s, followed by 2s, then 2p, followed by 3s, down to 3p, 4s, down to 3d, 4p, 5s, 4d, 5p, 6s, down to 4f, 5d, 6p, 7s, then 5f, 6d, 7p, and 8s. This is how to write the electronic configuration. Example, write the electron configuration of lithium. Lithium has an atomic number of 3. Atomic number is also equivalent on the number of electrons. Therefore, the electronic configuration is 1s2, 2s1. So if you're going to add the 2 and 1 here of the exponent, that would be equal to 3, which is the number of electrons. Next, you have sodium with an atomic number of 11, meaning to say there are 11 electrons. So we have 1s2, 2s2, 2p6, and 3s1. So if we are going to add this, it gives us a total of 11. Here are some other examples. Okay, next, Pauli's exclusion principle. Electrons occupying the same orbital must have opposite spin. Consider the electron configuration of lithium, which is 1s2, 2s1. So the orbital diagram, which will look like this one. This is the correct orbital diagram. Another one, consider the electron configuration of sodium. 1s2, 2s2, 2p6, and 3s1. So you have here the answer using the orbital diagram. Next, Hund's rule of multiplicity. When electrons enter a sublevel with more than one orbital, they will spread out to the available orbitals with the same spin before pairing. Example, the electron configuration of nitrogen. Nitrogen has 7 atomic number or 7 total number of electrons. Therefore, the electronic configuration is 1s2, 2s2, 2p3. The orbital diagram will look like this one. The 3 arrows here, they will spread out to the available orbitals with the same spin before it will be paired. Did you understand now? So here are some examples. So you have here the lithium, the total number of electrons. So if you're going to count the arrow here, it gives us 3 electrons. So the electron configuration, we have here 1s2, 2s1. Okay, we have beryllium, boron, carbon, nitrogen, neon, and sodium. Okay, let's have an activity. Write the electronic configuration of the elements and show the orbital diagram using the Hund's rule and Pauli's principle. Are you done, class? Here are the following answers. Check if your answer is correct. Do you have the same answers? Very good. Okay, for your assignment, you can comment below if you know the answer. Answer the following. Okay, that's all for today. Thank you for watching. Don't forget to click like, share, and subscribe. Goodbye!